Hey everyone, welcome to homework video 2.2. Today we looked at naming functions and using words to describe functions. So we're going to start by looking at this example with the height of water in a bathtub. W is a function of time t. Let P represent this function. Height is measured in inches and time in minutes. So for a lot of these types of examples, what I find really helpful to do is to draw yourself a little picture, right? So we have a bathtub. There's our bathtub, kind of. Okay, there it goes. It's a little laggy. And as the water is being filled up, we're measuring the height of the water in the bathtub, right? And so that's this height here of the water in the tub. And it's a function of time, meaning that this height of water is changing over time. So let's take a look at these examples. It says match each statement in function notation with a description. So P of 0 equals 0. So the function P of 0 equals 0. So this means that at 0 minutes, when we've just started, it has 0 inches of water in there. So this is the bathtub starts out with no water. Right at the beginning of the bath, there's no water in the tub. P of 4 equals 10. So remember, this input is the function of time. So the input is the time right there. So after 4 minutes, which is our time, we have 10 inches of water. This here is then the opposite, right? So the input here is time is 10 minutes. After 10 minutes, the height of the water is 4 inches. And then after 20 minutes, the bathtub is empty. That might mean that they perhaps drained it after a very short bath. Okay? All right. So again, the key point there is that this is a function of time, which means that that parentheses that's going into our function notation is telling us how long the water has been running or how long time has passed. And then that is equaling our water height, all right, in inches. All right, so function C takes time for its input. All right, so you can already go ahead and think about what that function notation would look like, and gives a student's Monday class for its output. All right, so then this is the Monday class on a given day. So it says use function notation to represent a student has English at 10. So we'll say subject like this, all right? So the function C of 10, right, that's the time at 10 a.m. equals English. That's the class that they have on Monday at that time. Write a statement to describe the meaning of C of 11:15 equals chemistry. So this would mean at 11:15, the student has chemistry on Monday. Function F gives the distance of a dog from a post in feet as a function of time. So we've seen this function now several times, right? Find the value of f of 20 and f of 140. So f of 20, remember, f of 20 is the t time. So I'm looking when we're at 20 seconds, what y value do we have, or what output do we have? So that would be about there. And we're going to estimate here. So I'm going to say that's not what I wanted to do. Let's say 3.15 feet away from the post. And so we would say f of 20 equals, and then f of 140 at 140 seconds equals, it looks like it's up between 3 and 4, so 3.5 feet. All right, number 4, function C gives the cost in dollars of buying N apples. All right, so gives the cost, so that means this is the cost. That means it is a function of the number of apples. What expression or equation what does each expression or equation represent this situation? So 5 apples costs $4.50. Okay, so again, buying N apples means that we have C of N. N is the independent variable, or the input, and then the output is how much it costs, or the money that we're going to pay for it. So C of 2 represents the cost of 2 apples, which we aren't given in this, so we don't know, but we know that it's going to represent, this whole thing is going to represent the cost of 2 apples. Number 5, a number of identical cups are stacked up. The number of cups in a stack and the height of the stack in centimeters are related. All right, so again, draw yourself a little picture, right? You have cups, that's a cup, and as you stack them, that's upside down cup, just so you know. As you stack them, right, the height is going to increase. So it's a function of the number of cups in a stack, and the height of the stack will change based on the number of cups. It says, can we say that the height of the stack is a function of the number of cups in the stack? So if we were to say, let's say we say S of the number of cups, where C represents the number of cups, equals height, is that a function? So for every time I put 1 cup in, am I going to get a new height? So if I put in 1 cup, I'll get a certain height, let's say 5 inches, right? I put another cup on top, now I'm going to have 5.01 inches, right? So it's going to change each time. And so we can say yes, because for each number of cups that we input, there will be a different height value, right? So for each input, there will be 1 output. Now the other question says, can we say that the number of cups in a stack is a function of the height of the stack? So can we say that S of H equals the number of cups? So if we're given a specific height, can that determine that the number of cups? And will each height have a unique number of cups? So this is actually also yes, because given a height, we will have different numbers of cups. So to put that in an example term, if I were to say, oh, it's 7 inches tall, right? The stack of cups is 7 inches tall. There's only 1 number of cups for which that would be true. If I said it's 7 inches tall and it could be 5 cups or it could be 7 cups, right, then that would not be a function. But because any given height that we have is going to give us a unique number of cups, then that is also a function. When in doubt, you can also try to give yourself a little graph to see if you would have unique values for each one too. All right, in a function, the number of cups in the stack is a function of the height of the stack in centimeters. So we already, this also it's a little cheap. Sketch a possible graph of the function of the coordinate on the coordinate plane. Be sure to label the axis. So it's the number of cups in the stack is a function of the height. So the function of height gives us the number of cups, right? Sketch a possible graph of the function on the coordinate plane. So if the input is the height, because it's a function of height, then the height is here. And if the output then is the number of cups, then that would be on our y-axis, right? And it's similar to what we saw here. And then it says sketch a possible graph of the function on the coordinate plane. So, right, let's say we're stacking not cups with nesting within each other, but cups straight up on top of each other, right? And the height, let's say we have 1-inch cups. I'll just make it up, okay? All right, and then, so every cup is 1 inch. These are little tiny cups, all right? And as we stack them on top of each other, then that means each time the stack is going to be an additional inch. So for every inch, we have 1 cup. That means if we have 2 inches, we have 2 cups. If we have 3 inches, we have 3 cups. If we have 4 inches, we have 4, 5, 6, and so forth and so on. All right. Now, this would depend on the size of the cup, how tall the cup is, how many cups you have, right, and how you're stacking them. So it could look a little bit different, but generally you should have a straight line, all right, going up with a nice even slope. It says identify one point in the graph and explain the meaning. So let's say 2, 2, 2, 2 is, we could write it as f of 2 equals 2 in a function form. And that means when the stack is 2 inches, there are 2 cups stacked on top of each other. All right, this is a review. Solve the system of equations without graphing. Okay, so because of the way these are set up, I would strongly encourage that you do these by elimination. And you're going to see review problems on every homework, just so that you don't forget the things we learned in the last unit. All right, so in seeing this, I see that I have opposite signs for both my x's and my y's, but 5 and 3 have a lower least common multiple. So I'm going to multiply this top equation by 3 and this bottom equation by 5 to get 2 new equations that I can then eliminate. So this will be negative 15x plus 9y equals negative 24. And then this one will be 15x minus 21y. Oh, sorry, minus 35. I was looking at the wrong numbers there. Minus 5 times 7 is 35. Y equals 5 times negative 3 is negative 15. Now I can eliminate my x's because I have an opposite sign here and same coefficient. And then we have 9y minus 35y is going to be negative 16y, or sorry, negative 26y. Ooh, goodness, we got a negative 26y equals, and then negative 24 and negative 15 will be negative 39. So you're not going to have a beautiful, perfect, easy number here, right? But the point is that I want you to get used to practicing these. So we'll get y equals 39 over 26. And then you would need to plug that back in to see what you would get for x. So that part, x equals, see if you can solve that yourself. All right. Our next piece then is looking at this one over here. And in this case, I have opposite signs here, but they're larger numbers. I have the same sign here, but they're smaller numbers. So you can do this either way. I'm going to go ahead and multiply this top equation by negative 3 and this bottom equation by positive 2. And the reason is because that will create a positive 6y here and a negative 6y here, which I can then eliminate. So let me make sure that I do all my signs correctly. Let me just put these parentheses out so I can see a little bit better. Negative 3 times negative 8 is positive 24x. Negative 3 times negative 2 is positive 6y. The whole reason I did that. And then 3 times 24, a negative times a positive, is going to be negative 72. Then down below, 2 times 5 is 10x. 2 times negative 3 is negative 6y. And 2 times 2 is 4. All right, now I can eliminate my y's. I will get 34x equals negative 72 plus 4 is going to be negative 68. So in this case, you will get a nice even number of x equals negative 2. Now you can go back and plug that in. All right, that is it for your homework. So you need to go ahead and go back and solve for y for this one because you're getting that practice, and solve for x on this one. We'll be looking for that tomorrow. Your code word today will be, let's see, what should I do? Micans. And if you can tell me what a micans is, I'll give you some more extra credit. All right, happy homeworking and see you tomorrow.